Hey everyone, Chang here and welcome to my channel. For today's focus on probability, it's not anything completely new. It's not a new strategy, a new way to compute, none of that. Today I want to focus on 4 components of probability that is so easily missed that actually a good number of the reason why certain answers or certain problems are solved incorrectly is because we don't focus on these key components. Now, the key component is right here. We have independent situation, dependent situation, and situation or situation. Now, or there are situations where it actually differentiates between 2 different ors. There's the inclusive or, which is one or the other or both, right? That's the inclusive or. The other one is exclusive or, right? And that's actually, I want to say, a majority of the situation that you will end up seeing is what we call exclusive or. So to think of exclusive or in this situation, let's think about when you normally go to a fast food, or not even fast food, just any restaurant where you order a meal and it comes with sides, right? Usually it has a list of sides. It says maybe fries or salad. Well, intuitively, we know that we're choosing either fries or salad. We're not going to get both. That's exclusive or. That's one or the other, but not both. And that's a majority of the situation. Now, every now and then you have the or both, right? So that means you could get potentially 2, which I haven't seen a restaurant like that. If you have, recommend it to me so I can go check it out, right? So here's the thing. These 2 are usually sort of, I guess you could say, related together, right? A problem is going to be either independent or dependent, one or the other, and it's going to be a combination of independent or dependent with the and or, right? I guess pun intended, right? So these 2 are always going to be part of it. These 2 are always going to be part of it, and there's always going to be a mix. It could be independent and dependent or you know, any combination of those guys, right? So let's just actually differentiate what's the difference between each of them. Well, independent in this case is that the current situation, current scenario situation, whichever word you want to use, is not dependent on previous, not affected by previous like situation. Usually it's sequential situations or one that happened after the other, right? The current situation is not affected by the previous one. So you can guess that dependent is that the current situation, it is affected by the previous situation. Is affected. Affected? Sorry, grammar's not that great. I think affected. So let's change that. Affected. Right? By previous situation. And with and, you can guess both situations. And this one is either or, but not both. So these seems like arbitrary, ethereal, like sort of you can't really grasp kind of concept until you actually see problems that actually utilize this. So even though I just briefly showed this, and you know, with error of course, let's look at some problem itself so that it actually becomes more clear. When you see examples of it, it makes a lot more sense. So let's just move on to the first problem. Alright, so we have this scenario where both of these are going to be based off. The scenario is going to be a bag with 4 blue balls and 3 red balls. Very simple in that case. Now, these 2 are slightly different. One of them is going to be independent, one of them is going to be dependent, right? And hopefully you guys can sort of see it. But let's look at the independent. The probability of selecting a blue ball and a red ball with replacement. So notice the idea. In this case, it makes it pretty obvious with replacement. That means when I get one of the balls, I'm going to put it right back in the bag and then select a second ball, right? So the probability of selecting a blue and then a red ball with replacement is fairly simple. Well, there's 4 blue balls and the total of them, there's 7, right? So the probability of selecting the blue ball right here, in this case, is going to be basically 4 over 7. And the probability of selecting a red ball right here is going to be 3 over 7, right? Because we put the ball right back. So if we want the probability of getting a blue and a red ball, we just multiply these guys together, which gives us basically, if you multiply it, it's going to be 12 over 49. And you can go on and on with figuring out the decimal or the percentage. We're not going to go into that. But look at the dependent situation. In this case, the probability of selecting a blue ball and a red ball without replacement. Now, so you see the difference, right? This one is without replacement, meaning that when I get one of the balls out, it's staying out, right? We don't have another situation where it's like, all right, cool. I grab it and I put it right back in, so the number of balls is still the same. So because I grab one in the first scenario, my current one, the second one that I'm thinking about, right? The number of balls has changed. That's what is the difference between independent and dependent. So the first part is still the same. We're looking at a blue ball, all right? So in the first case, we still have 4 over 7 possibilities, right? Now, assuming that we grab the blue ball in our first draw and we take it and we leave it out now we're looking for the probability of a red ball. Well, in this case, it's still going to be 3 because our first one is a blue ball. But because we took that blue ball and we put it out, now instead of having a total of 7 balls in the bag, we actually have a total of 6. So notice that that is actually very different. So that means now the probability is going to be 12 out of 42 instead of 12 out of 49. So this one actually is a higher probability, right, than this guy right here. They're two very different things. Same scenario, but one of them just happens to be independent and one of them happens to be dependent. Hopefully you guys can sort of see why it's so easy to make a mistake when we actually don't differentiate between independent and dependent situations. So let's look at another problem. All right, so we have this second situation. I've changed the scenario a little bit, so hopefully you guys realize that. Bag with 4 blue balls, same thing, 3 red balls, and 2 green balls, right? So added another variable to it. Now, here we have again independent, dependent with the or instead of the and like the previous one. And notice this, the problem is slightly different as well, just so you guys can actually see what's going on. The probability of getting a blue ball or a green ball with replacement. So the idea is that when I draw one of the balls, I want to see the probability of getting either a blue or a green. And that's fairly simple, right? With replacement, without replacement, if it's a scenario where you're only drawing one, that's more than enough, right? So a blue ball, well, there's 4 out of a total of how many? That's 9, right? 9 total. So if we're looking at the probability of a blue ball, in this case, is going to be 4 out of 9. The probability of drawing a green ball, right, is what? 2 out of 9. And so when we draw, what's the probability of drawing a blue ball or a green? So it's either one of those situations we want, right? Then we can just actually add the probability together, because I mean all we really need is A, right? 1 or the 1, right? So it's just 1. So if we add them together, is actually the probability is just going to be 6 over 9. So notice that we're not multiplying in this case, we're actually adding the probability because we want the situations where either of the scenario works, right? Instead of it has to be both scenario at the same time, this one is either that or that. So we ended up adding the probability together. Let's look at this one. This is one where it's dependent because you're actually drawing 2 balls now. You want a situation where either you get 2 blue ball or 2 green ball, right? Without replacement, of course. Now, without replacement, once again, you're not putting it back, so you got to be a little careful. What's the probability of getting this situation? 2 blue balls. Well, in that case, it's going to be, first one is going to be 4 out of 9 because 4 out of the total possibility. Then we have the possibility after you draw the first one, you want the second one to be a blue ball as well. So it's going to be 3 out of 8 instead of 3 out of 9, right? Because you're not putting it back. Well, let's look at the green ball. Same scenario. Well, if we want just green, we have to have the first one be green and the second one be green. So the probability of the first one being a green ball is going to be 2 out of 9. And the probability of the second one being a green ball is 1 out of 8. And so if we want to find the probability of either one of these scenarios happening, or, right, you can just add them. There it is, right? And then of course the bottom is going to be 72. You guys realize that? This is 12 plus what is that? 2, that's going to be 15. And just like that, that's the probability for this guy. And I should probably just put this here to mark the 2 different answers. So there you go. Independent or dependent or. Alright, so when you normally encounter a problem, of course, it's not going to be explicitly highlighted whether it's independent, dependent, or and or, but when you read the problem itself, you have to be able to at least differentiate a basic, I want to say, common sense kind of interpretation to figure out if it's and or, if it's independent or dependent. So let's look at this one. You have a standard 52 deck, right? So a standard 52 card deck, and you draw 4 cards. What is the probability that all 4 cards are spades or all 4 cards are hearts? Well, at least this one has the or, so we know this is an or situation. And you're drawing all 4 cards, right? So most likely this is a dependent situation because you're not going to draw one, look, and put it back. It didn't say anything like that, right? If we're looking at it through a sort of like a common sensely, maybe general situation kind of lens, it's most likely you draw 4 cards, one after another, 4, and then look at it, hoping that it's either all spades or all hearts, right? So if we're going to look at that, we just look at these 2 different scenarios, and since it's an or, we're going to add the probability because we want one situation or the other, right? We're happy with either one. Well, the first one is 4 cards are spades, and the second one is 4 cards are heart. Well, luckily for us, if you've played with standard 52 deck, they're pretty much the same thing. There's 4 different, like, I guess you could say type or suites, right? So spades is one of them. The first one is going to be a 13 out of 52, right? There's 13 of those cards, all from ace all the way to, jack, king, queen. And then after you draw the first one, the second one, you also want spades. And since we're drawing it one after another without putting them back, it's going to be 12 out of 51. And then, of course, 11 out of 50. And then 10 out of 49, right? That's the first situation, 4 cards that are spade. Well, luckily, hearts is the another suite, right? So in other words, it's going to be the same probability. So in that case, it's going to be 13 out of 52, 12 out of 51, 11 out of 50, and 10 out of 49, right? That's the second one. Well, what we're going to do is we're happy with either one of these situations. So all we have to do is just add this probability together, right? And then, of course, I'm not going to go through just calculating the whole thing, but it's basically going to be, well, you guys can sort of see, right? 2 times, it's going to be 13, 12, 11, 10 on top, and the bottom is going to be, well, 52 times 51 times 50 times 49, and if you are more inclined or whatsoever, you can definitely calculate it by hand or enter it into a calculator and actually find out the exact probability of either one of these situations to occur. All right, so there you have it. We're at the end of the video. Now, this, once again, it's not to introduce anything new. There's no new skills, no new technique, none of that. This, I'm just trying to highlight the exact factors of certain probability problem. Of course, there are more complex one that is an intermingle of a lot of different factors and it gets super convoluted. But the idea is that every time you look at a probability problem, always ask yourself when you're reading the problem, is this a situation that's going to be independent, meaning that the first scenario and the second scenario doesn't really affect each other? Or is it going to be dependent, where whatever happens in the first one, the second one is going to change, right? The other one is you want to ask yourself, is it an and situation where I need all those different scenarios to occur for it to match the problem? Or is it going to be an or situation where basically I am happy with any one of the possible cases, right? If you're always asking yourself those questions every time you read a basic probability problem, most of the time you can avoid the simple misreading, misunderstanding kind of mistake that actually occurs really frequently. So hopefully this helps. It highlights, emphasize, show out the different, I guess you could say, differentiating factors, and it will help you with your future endeavors in probability. Thank you for watching this video. If you haven't already, please like, comment, and subscribe. I will see you in the next video.